Okay, Chan. A quick video to explain what's happening on the static charge one worksheet. So the first thing you were supposed to do was draw a copy of the atom, or draw a model of the atom. And so you can see from this model, what we have is we have a nucleus that has protons and neutrons in it. This is all the mass from the atom. There's very little mass in the electrons. And you can see that, I guess, this one has 4 protons. And so there should always be an equal number of electrons in the natural state, meaning like we haven't done anything, we haven't rubbed anything to pull the electrons away, we haven't pushed electrons or something around. So in the normal state, the number of electrons and number of protons should be the same. And then it's only when we do something like rub the fur on the PVC that we can then transfer those electrons, and then those electrons will be missing. So you can see the second part of this model right here outside the nucleus is the electron cloud. And so we have those electrons out in the outer shell. So we have 2 in the first shell and 2 in the next shell. But basically that's what's going to happen is as those electrons come in, they're going to be first real close, the first 2 are real close, and the next 8 are really in the next shell, and then we keep building shells further and further as the atom gets bigger and bigger. Okay, so the second part talks about a little experiment that 2 people are doing, and the first question is, what kind of charge should everything be? So the one thing that we didn't do on Friday was use silk. Silk has the ability, instead of to give electrons like the fur was giving electrons. We saw that kind of sparking out, and we could hear it going onto the PVC, and so then there were electrons on the PVC. Silk has the ability to pull electrons off of something, so that's the exact opposite. So if you rubbed silk on a PVC pipe, you could pull electrons off of it instead of put electrons on it, and therefore the PVC will be positively charged. It's just not as great, and it's not as dramatic as a fur, and so we didn't do it. But anyway, so the first question says, what's the charge on all of these things: the wool, the styrofoam, and everything should be normally neutral. And so that's what the first question is, that it should be neutral. All right, the second question then asks, what after the styrofoam was rubbed with the silk, they said that the 2 of them were attracting each other. And so if something is attracting each other, we know that they're opposites, because opposites attract. And so no matter what you know about like which one has more electrons on it and which one is missing electrons, the bottom line is if they're attracting each other, they should be oppositely charged. And so that you should be able to figure that out just from the fact that they were attracted to each other. So then the next part asks us about which one's positive and which one's negative. And so we just know that the fur is the thing that's going to be able to give electrons, put electrons onto the cup, and then the one that's positive would be the one that was rubbed with this silk. All right, and then this question D says, your friend says something about scraping protons, and this is one of the things that I talked about on Friday. That's just absolutely impossible. The protons are the thing that make up the mass of the atom, and so they're the things that make a desk, and make a styrofoam, and so you can't scrape protons off of anything. The only thing we move is electrons, and we've been talking about that a lot, but we want to make sure that you guys get that you cannot move a proton, you can only move an electron. All right, so the next question talks about Natalie, and so the idea here is how's Natalie, who's going to be, or Natasha, how is she going to become charged? And so we saw this in the demo yesterday, but I can show it to you guys again. If somebody walks across the carpet and they scrape their foot, a carpet, just like wool, is going to want to give out electrons. Sorry, let me move this hand right here. So if you walk across a carpet, eventually these electrons are going to start building up on your body, and you're going to become negatively charged. And so the one thing that's a little bit strange about electrons is because they're all negatively charged, they don't want to be anywhere near each other when there's too many of them. And so you can see as we built up electrons on this John Travoltage right here, that they all spread out. So they're spread out all over his body, and we'll see that again in another example. So we see that his body now has built up an electric charge of negative charges. And so when he gets close to a metal object like the doorknob, those charges are going to want to flow to them. You can see them come by like a spark. So sometimes if we're close enough, the charge will want to move through the air. And so and then you can see that that electron discharge off of his body into the doorknob. And we always said that, you know, the doorknob shocked us, but it's the exact opposite. We're the ones that have the extra charge on us, and so we're the ones who are shocking the doorknob. And it's always right, the finger or something like that that's closest to that, and the finger has all these extra nerves in it, so that's why it hurts, because when you shock through the through your finger, you're going to feel it because you have so many extra nerves there. All right, so the next question is really kind of tough, and so I want to just help you guys out a little bit by drawing it out for you. But this is about, let's get that back up here. This is about the example that I showed you guys with the PVC pipe and the Coke can. And so this is very similar. We've got a rabbit, we've got a block of styrofoam, and then we've got a sphere, okay? And when we start out, they should all be the same. So we've got everything should be the same charge. And so when we draw that right here, when we draw that, we see that we can have positives and negatives, but there's the same number around the rabbit, there's the same number around the piece of styrofoam, and there's the same number positives and negatives around the sphere. Okay, and so that's normal charge. And so when we then rub this right here onto the rabbit, well, now we're going to demonstrate that we're going to negatively charge the styrofoam. So we're going to rub the rabbit. The rabbit's going to give us some extra electrons. And so instead of there being an equal number, we're going to have a number that's going to have extra electrons right here. And so when we draw that, we see that even though they have all those positives and negatives from before, the rabbit has given us extra electrons, and so there's a negative charge right here. And so there's more charge right here. So that's what we're trying to do, is just show that there's more charge. All right, so then what happens then when we take that styrofoam and bring it near this ball, right? And so that's when we took the PVC and we took it and we brought it next to the Coke can, and all of a sudden, for some reason, they were attracting each other. And so the can followed along with the PVC pipe. And so we would say, well, they have to be differently charged. If one is going to be attracted to the other, opposites attract, not same charges. So the question is, what's happening? We know that the block right here is negatively charged. We have it, but what's happening here? And that's what we're trying to ask you guys to draw. And so what happens is that when we get this negatively charged block right here that's got all this negative charges, comes near here, well, now those electrons want to go somewhere, and they want to go away. And so what happens is, because this is a metal ball, those electrons can move in a metal, just like in a wire or anything like that. And so those electrons all move to the opposite side. They all just kind of shift over. This is what we call polarization. This is when half of an object is positively charged and half of it is negatively charged. And so as this gets close, and they're not going to touch, they're just going to be close enough so that the electrons want to run away. They run away to this side, and all of a sudden this ball becomes positively charged. And because this is negatively charged and this is positively charged, it's going to start to roll towards it. It's going to be attracted. That there's a force for that. And as that's happening, it's really neat about a metal ball is that as it's happening, those electrons, of course, are still not wanting to be anywhere near each other. So they will always stay on the furthest side from the styrofoam. And so they'll just keep moving around. And as this rotates, they'll move opposite, so that they'll always be right here. And so that will allow us to continuously pull this. We could pull it all the way across the classroom if we wanted to. All right, so that is the end of it, and it says, is the metal sphere in stage 3 charged? It is not necessarily charged in the fact that it has extra electrons or has lost electrons, but it is polarized because half of it is negatively charged and half of it is positively charged. All right. Okay, so that's that worksheet. Turn that one in, and then we'll move on to Coulomb's law.